So I took the board out of the case and discovered a couple things. One was it's obviously been dropped, probably why I bought it for $6. This connector here is all out of whack, so something was plugged into it and it really wrenched it. I'll probably never use this input, but I'll go ahead and see if I can't bend that one back in. I did also notice that when it got dropped, it cracked the power input cable connector as well. There's a big, I don't know if you can see that, but there's a big split right here. And since that connector didn't fit my AC adapter, I found in my junk bin a connector that does fit. So I'll just replace it. So I'll get a new one and it'll fit. So I don't have to rewire that wall wart. So I'll do that. And the reason I took it out is I was gonna put some heat sink, try to find some heat sinks that fit this cramped area here, and put those on the 3-terminal regulators here. But while we're here, take a look at it. It looks like there's been some rework on it. Oh, these connectors got added after the board was flowed. That makes sense. This capacitor looks like it's been reworked, so that's interesting. And the LEDs got reworked, so I don't know. So maybe they just touched up some solder joints that looked funny, or maybe there's a solder bridge or something. But otherwise, it looks real clean. Looks pretty good. Yeah. All right, got that desoldered. Come on, out of there. There we go. Looks pretty clean. There's an extra hole there. That's interesting. Oh, that's the, it's for the screw. All right, this is where you need 4 hands to hold everything. I'm just going to tack it in place here. There we go. Oops. See? Like I said, you need 4 hands. And it doesn't help that you've damaged yourself. Had to go to the emergency, not emergency, but urgent care. Get a couple stitches in my finger. Oh well. They said a lot of people are home and doing a lot of home improvement projects because they're stuck. And they see a lot of people damaging themselves. So I guess I fit the category. Oh well. It wasn't a garage accident though, it was a gardening accident. Well, it's sort of a garage accident. I was sharpening a gardening implement. I think that'll do. Good as new. And my wall wart now plugs in. Yay. Excellent. Okay, so the next thing to do is figure out how I can put some heat sinks in. Let's see. Might have to bend these different directions, snip them off. I think that one will fit if I bend these guys out or snip them off. This is going to be a trickier one. I'll have to find a different one for that one. Let me scrounge around my junk bin. So I found a solution here. I found this heatsink, which is a slip-on variety. And it's nice and tiny, so I can get it to slip right on there. And then I took this heatsink and bent the bent the fins out so it misses all the components in here. And I'm going to have to bend this one too. There we go. So that misses everything now. I go that way. And this one, oops. This one bends, should miss the case, so put some heat, silicone heat compound, and put these together. Let's see, I think I'll do this one first. It should be good. And again, I need 6 hands. All right, that worked. Now maybe I can hold the, what I need is my hemostats. The hemostats are great for holding nuts. So there, see, it's holding all by itself. And I can get the nuts started. There we go. Done. All right. And oops, make sure it's straight. Okay. Now this one's going to be a little trickier. Let's see. I think we'll have to bend some things on this one as well. Bend these out a bit. There we go, that'll work. Okay, put some heat shrink on that, or heat compound on that. I think I need to put it on the transistor this time. All right, slide that on, and I think that will do. So here's my here are my heat sinks. So this is kind of the push-on variety. Let me put it into manual focus here so I can show you better. This is the manual slide-on one. And the other one is just a regular one, but it's been flattened out. So those fit nice now. The connector's done. I was able to fix this connector over here, which was bent when it was dropped. Seems better now, and it powers up. I did measure. I was worried about this heatsink touching the case and shorting out. I wanted to make sure it wasn't touching, because sometimes the tabs of transistors are not what you think they are. A lot of times the 3-terminal regulators, the tabs are ground, but not always. So you need to check. So the tab of the plus one was ground, but the tab of this minus one is actually the input voltage. So there was actually minus 24 volts on this tab. So that's probably why they get so darn hot. Minus 24 volts drop down to 15. You're dissipating 10 volts with just doing nothing but heating. So that wasn't good. So button it up and see if it works. I don't really have a microphone to try it with. I've been kind of holding off on that, buying a microphone. I kind of want to kludge one together. So I have some boards, but I don't have the microphone case yet. I need a donor microphone to put the parts in, so I'm waiting for that. So as soon as I get that, we can put a microphone together. So I said I didn't have a microphone really to try out. I have this thing, which is the guts out of BM700 or BM800, one of those microphones. And it's a quote condenser microphone. It's actually an electret microphone, which I guess is considered a condenser, but not the big diaphragm condensers that you think of. And doesn't require doesn't require 60 volts on it. In fact, it uses 0 volts. It has pre-charge on the diaphragm. Anyway, but something about something else. So here's the circuitry for that, and I've hooked it up to an XLR connector, so this will now be my microphone. So we will plug that into the number 1 slot and turn that on. And I have a oscilloscope hooked up on the output, and I'll show you what that looks like. So we're having all kinds of 60 hertz ripple, really ugly looking ripple from fluorescent lights and things like that. Anyway, all kinds of crazy things. And if I adjust the, I'm going to adjust the gain setting on microphone 1, and you can see that that is basically coming, if this is all the way down and this is turned up, so basically that's coming from the microphone. The microphone's picking up that hum, and that's because the microphone isn't shielded. So I don't have a donor microphone. Like I said, I need a body so I can shield this thing. That's why microphones come in metal cases and metal mesh around the microphone. It's to shield it from all the other stuff. So, but I do have a tube off of a paper towel dispenser, and I wrapped it in aluminum foil. So that will become my microphone body. So I will slip this over. Okay. And you can see that we're still, we still have a signal. That's because the aluminum foil isn't shielded, isn't connected to anything. So I'm going to short out the shield to the ground pin on the back here, and you can see that our noise went completely away. So now, if I turn up the gain of the microphone, hello, it's starting to pick up a signal. So let me turn my iPhone on again with that song. So we have some audio going in. Turn up the gain. Let's turn this up. Oh, and my song stopped. Hello. Why did my song stop? There it goes. So, I said it's a success. Looks like the audio buddy works, and all you need now is a good microphone. But we're getting good amplified signals out now. My microphone case probably leaves a little bit to be desired, but it does work.